In this lecture, we are going to describe RC series circuit. The level for the present discussion is O level or A level. In this, we are going to describe RC series circuit. There are two possible combination in two component series circuit. One is RC circuit and one is RL circuit. Suppose here first we want to describe RC series circuit. For this, to keep the thing as simple as possible, and also we want to prepare this for exam purpose, so we will keep the things as simple as possible. Here we consider a circuit consisting of resistance R and capacitor C connected in series as shown in figure. Here is the figure where we have seen that there is a capacitor and there is a resistor, and also here is an AC power supply, mean an alternating voltage source is applied. When this alternating voltage source is applied, a current I flows through the circuit. We take this current as IRMS current, and as a result there would be a potential difference between these two components, which we designate as VRMS. From this figure we can also see that the total potential difference between two terminals of the potential providing source, which is now called AC supply. This total potential split into two potentials, that is one potential across capacitor and the other part of potential is across resistor. For this circuit, the main idea is to calculate the IRMS and VRMS, and from that relation we will calculate impedance of the circuit. So first of all, our major purpose is to find the relationship between VRMS and IRMS. For this, we consider the current flowing through the circuit is IRMS, and due to this flow of current, the potential difference across the resistance will be IRMS into R. This is from the formula of Ohm's law, and Ohm's law is V is equal to I R, where V is the potential difference and I is the current flowing through the circuit and R is the resistance of the circuit. So this is the formula IRMS into R. Next, we also know that the potential difference across a capacitor will be equal to the current flowing through the capacitor and capacitive reactance. We know that the capacitive reactance Xc is equal to 1 over omega c, where omega is angular frequency and c is the capacitance of the capacitor. This formula, this relation for the reactance we use here without driving this relation. Also, in this topic, we are going to find the relationship VRMS and IRMS using vector representation. So, first of all, we have to represent the different quantities, that is current, voltages across resistance and capacitor as vector as vectors. So in order to draw this vector relationship, we take the current as reference and vector I is drawn horizontal. The vector for potential difference is also along the current because current and voltage are in phase. This means that whenever we want to draw circuit, want to draw the vector diagram for a given uh, AC circuit, then we must have some reference vector. A reference vector is usually chosen by keeping in mind that this quantity should have zero value at t is equal to 0 at the starting point, or at the time which we take as a reference. What is meant by the time as a reference? This means that whenever we have some physical one or two or more alternating quantities, and we want to represent uh, their vectors, then one of them must be drawn horizontal at the time when its value is 0, and then all other quantities, the vector of all other quantities will be drawn according to with reference to this initial physical quantity. For the present case, we take current as a reference. So here we see that the vector for the current is drawn horizontally, and since in case of resistance the current and voltages are in phase, so we also draw the vector for resistance, for vector for the potential difference along the vector for the current. So in that case, the voltage VR is equal to IRMS into R will be represented by a horizontal vector along the same direction as the current. Now we know that the voltage across the capacitor lags the current by pi by 2. So the potential difference across the capacitor, which is written as IRMS XC or IRMS over omega C, is taken as taken along taken behind the vector I by pi by 2. So in that case, in this figure, it is represented by a green vector vertically down, and actually it is pi by 2 behind the current. And from figure we see that the resultant of VC, that is voltage across capacitor, and VR, that is voltage across resistance, will be VRMS. And from this vector diagram, the resultant of these two vectors One is representing VC and other is representing the VR. Then this the vector sum of these two voltages will be actually the VRMS. So from figure, the applied voltage VRMS is obtained by the resultant of vectors IRMS I into R, and for this represent for these calculation we consider the figure above. In this figure, the vector VRMS is the sum of two vectors, and we use the parallelogram law of vector addition, and this will give us VRMS is equal to IRMS R whole square plus IRMS over omega C whole square. And VRMS, here is IRMS square, here is also IRMS square, so we taken out the IRMS square, but we are left with R square and 1 over omega square. Now the impedance of the circuit is Z is equal to VRMS over IRMS. This is the definition of impedance of the circuit. From this relation, we take VRMS over IRMS, which is equal to R square plus 1 over omega C whole square under root. So this is the impedance of the circuit.